Hello, it's Clozapine Fit and Lean here. I just want to make an extended video about clozapine's metabolic disturbances because I now have a bit more YouTube time in terms of length of videos. So, I want to go over basically a bit more detail about the metabolic disturbances of clozapine. Okay, now, clozapine is unlike sort of the newer generation of antipsychotics such as aripiprazole. Aripiprazole is what we call a partial agonist of dopamine D2 receptors, and it's selective. Okay, now clozapine, and one of the reasons why it works so well is because not only is clozapine an antagonist, it's also a modulator, and it hits a whole broad range of receptors, non-selectively. Okay, so what happens here is, you have your D2 receptor, okay, or D2-like receptors, also including D4 receptors. You have this this benzodiazepine structure, okay, you have chlorine on it, which polarizes this molecule, and what it does is, because it's then electronegative in one part, is it doesn't just bind to the receptor, it spins around in it about 200 times a second, and that's how we think it alleviates psychosis. It does this in particular parts of the CNS, such as the nucleus accumbens, or the VTA reward pathway. Also as well, is it hits serotonin, and the reason why it has side effects in terms of metabolic disturbances is because it just hits loads of receptors, okay, huge amounts of them, a big whole list of them. Okay, and that's called what we call promiscuous receptor activity. Now, please, these are the theories as to why clozapine causes metabolic syndrome, so type 2 diabetes mellitus and obesity, is that when you look at the pancreas, okay, you have this thing called, in the pancreas, called the islet of Langerhans. So, you have what we call the alpha islet and the beta islet. That's sort of the main, sort of disturbances that go on with clozapine, is that, the alpha islet basically, or alpha cells of the islet, they produce an endocrine, hormone called glucagon, okay? The glucagon basically is supposed to regulate glucose metabolism, and the beta islet cells of the islet of Langerhans essentially produce insulin, okay? So, unfortunately, we have these same receptors that are found in the CS which alleviate the psychosis symptoms present in, say, the islet of Langerhans on the alpha and beta, islet cells. Okay, so you have muscarinic 3 on there, you have dopamine D2, serotonin 5-HT2A, and serotonin 5-HT2C. These receptors, okay, on the beta islet cells and the alpha islet cells, so it causes basically this, irrespective of blood glucose change rise or fall, it causes, this disturbance of, glucagon, how to say release. It causes basically the, glucagon to over-secrete, which messes around your glucose metabolism adversely, and also what happens is you have this, what we call this, this hyperinsulin secretion, this hyperinsulinemia, where basically your serum concentration of insulin is, basically much higher than what it ought to be, irrespective of blood glucose change rise or fall. So you have this high insulin serum concentration all the time. Now, insulin is your primary energy storage hormone, and I'll go back to what this basically means in a bit. Okay, so we also have another hormone called leptin. Okay, so leptin is our sort of energy regulatory hormone. It sort of governs things like non-exercise activity thermogenesis. Okay, it governs things like, for example, appetite, so energy intake, and energy expenditure through, say, upregulation or downregulation of thyroid hormone output. So directly by the thyroid gland itself is T3, and also the rate of deiodization, okay, of T4 into T3, and also, for example, T4 into reverse T3, which is the inactive steroid of, T3. So what will happen here is, because you have this high insulin all the time, okay, is you give what's known as something called proximal leptin resistance, where the medial hypothalamus basically does not recognize that leptin, and we now see is theoretically, this is what's thought to happen theoretically, is that you have this problem where the medial hypothalamus has the proximal leptin resistance, and this causes a downregulation of TSH secretion, okay, so thyroid stimulating hormone by the pituitary gland, and now what you have essentially is this downregulation of deiodization of T4 into T3. Okay, you get reverse T3 instead, which slows down your basal metabolic rate by about 200 or so calories a day. Okay, and furthermore, we also see as well on the level of the The liver, okay, the hepatocyte is, you get this what we call a histamine H1 signaling impairment. Okay, the histamine H1 antagonizes the hepatocyte, basically disallows for the insulin cascade mechanism to occur. So, what's happened, you have this sort of the alpha, part of the receptor and the beta part of the receptor, it sits sort of on this membrane here. Insulin's supposed to, to come along and activate this. Tyrosine kinase activates, it phosphorylates something called, PI2 into PI3, and then what you have here is this cascade of things that's supposed to happen. Now, because that doesn't work, basically it renders the liver insulin resistant. Okay, now you have an upregulated rate of hepatic glucose output, so gluconeogenesis de novo. Okay, and now what you also have is through antagonism of the serotonin 5-HT2A and serotonin 5-HT2C receptors on the liver, is you now have down-regulated glycogen synthesis. Basically what this means, instead of your liver acting as a glucose sink, it's now flipped the other way around, as it's now excreting glucose and not acting as a glucose sink. And then also, furthermore, what we have here as well is we have insulin resistance at the level of the periphery, say the muscle tissue, skeletal muscle tissue. Now, again, what usually happens is through the alpha part of the insulin receptor being activated by insulin, which then activates this tyrosine kinase, the beta part. What we are supposed to see here is an insulin-mediated cascade mechanism, a phosphorylation cascade, also protein kinase cascade. What's supposed to happen, okay, is you have this little vesicule, in the cell, okay. You have your thing called GLUT4. It's very small. There's supposed to be like 30,000 of them, if I remember correctly, on the plasma membrane surface of a muscle cell. You have your little GLUT4 within this little vesicule. Okay, it's supposed to, in response to this insulin cascade mechanism activated by insulin, it's supposed to what we call, translocate out to the plasma membrane surface, where this little GLUT4 will now scoop up, all this glucose from the bloodstream. Okay, so glucose uptake transporter 4. Now, just like liver cells, because you have histamine receptors on the liver of the periphery, namely histamine H1, clozapine antagonizes that. Okay, and now you end up with a similar thing going on from the liver in the periphery, is you basically have, what we call, what's it called? This insulin-mediated cascade mechanism not to work correctly, so you don't have change in gene expression or cellular growth. You also don't have this GLUT4 translocation. So what happens here is, just like your liver, which is supposed to act like a glucose sink, is your periphery now cannot act as a glucose sink. So, if that, glucose is not being disposed of into the muscle cells, where it's supposed to be polymerized into glycogen for further use later on, or oxidized by the mitochondria, basically substrate to produce ATP as energy currency. If that can't go on, you cannot favorably partition that glucose, that blood glucose, into the liver or into the peripheries. You now have a problem. Okay, is that glucose, that energy, now has to be stored somewhere else. Okay, and that's your fat cells, and because that insulin is always raised, okay, is your insulin is your energy storage hormone, and now what happens basically is that energy is now essentially told, is told by the insulin to be stored around your waist. So you get visceral fat. And what happens if you dangerously accumulate, a large quantity of visceral fat? It's inflammatory. You get these inflammatory cytokines. I think one's called interleukin 6, and you get free fatty acids. And we have this thing called the portal hypothesis, where basically, you have something, it's called the portal vein. What happens is this gunk, okay, this inflammatory cytokines and free fatty acids now infiltrate the liver, where it becomes fattily infiltrated, which makes it even more insulin resistant. It doesn't work correctly, and what you'll now see is your insulin kinetics go awry. Okay, what happens here is you now have essentially your liver's inability to clear insulin or fold insulin. Okay, so now you have, unfortunately, this problem where you have this insulin resistance systemically from the clozapine, as well as this hypophagic appetite, and this causes people to gain about 25 kilos on average, and they can't keep it off. If they lose it, it just comes back. You lose 5, gain 7 back. Now, okay, so what you're supposed to do? First of all, as I say, you've got to deploy a proper dose of metformin. Okay, if you deploy the proper dose of metformin, this somewhat removes the hyperinsulinemia problem. Okay, and that has this knock-on effect where it ought to also remove the the proximal leptin resistance problem, which should also then, as a cascade sort of reaction, somewhat normalize your basal metabolic rate, because you now have T4 deiodizing into T3 rather than deiodizing into reverse T3. And also the metformin does a good job at sensitizing the liver to insulin, so you have a down-regulated rate of hepatic glucose output, so down-regulated glucose neogenesis de novo. And also, if you do your weight training, okay, the forcible contraction of the muscle tissue causes the GLUT4 to what we call forcibly relocate to that plasma membrane surface, so now your muscle cells can act as a glucose sink. Also, I found really great success, using this berberine capsule. Now, this really works very well. Not only may it, okay, theoretically may, sensitize the medial hypothalamus to leptin. What we also see as well is it works through this, what we call the AMP kinase, pathway, which is sort of this master regulatory energy switch. And what we see here is basically, for some reason, okay, which is very complicated, which you get to fully understand, if you pair the metformin with a proper treatment dose for metformin with the berberine, is you have this effect where I can take clozapine, moderately eat, moderately exercise, my weight doesn't just keep going and going and going, up and up and up. I'm now able to normalise my weight. In fact, I've now lost 25 kilos. I'm trying to find there is a photo, I think it's buried underneath my supplements. 1 minute, I might knock the camera over by mistake. But I'm just trying to get it out here without knocking the camera. 1 sec. Okay, so at one point, I had a 55-inch waist. Okay, this is me. Okay, I'm 300 plus pounds, yeah? You can easily see I'm completely obese. Now, this is me now, minus 25 kilos, okay? Yes, there's still work to do. However, the stomach has come down a lot, okay? Now, please, there's also other theoretical things that we can do to attempt to shift fat, build muscle. As I said, you don't want to just run on a treadmill to try and burn calories, because your body is very mechanically efficient. You have to have the medications for insulin sensitivity, okay, and insulin reduction. As I say, there are more things that you can potentially do. So you're supposed to, as someone in my situation, is you're supposed to essentially encourage healthy eating habits alongside the use of metformin and berberine with resistance training exercise. As I said in the other video, if you build that muscle up, unlike obesity, which does not take much of an energy, sort of intake, with a surplus to maintain itself, maintaining a muscular physique does require a lot of energy to maintain itself. So, the more muscle you have, the faster your basal metabolism is. You have to build a good 30 or so pounds of tissue and then lose the fat afterwards. And this allows you to, with not strenuous cardio, but moderate cardio, so don't injure your joints, for example, running on a treadmill, is then you are able to put your body into a caloric deficit far easier, because you have the fast basal metabolic rate. You run on the treadmill, moderately walk on the treadmill, sort of 3 times a week for half an hour, and this is enough exercise to get you into good shape. So I've got the the arms, they're doing quite well, okay, so you can see I have quite a developed amount of musculature. I have muscly legs. You can see I can do the pec bounce thing. What this basically means, okay, is unlike a lot of people which basically have to exercise to create a calorie deficit, starve themselves, so it doesn't work, it's non-sustainable, and they regain it back because they've starved themselves. Instead of being like 1,200 calories a day and running on a treadmill, I'm losing weight rapidly on 2,000 or so, 2,500 calories a day while enjoying my diet. And now, because I have the muscle mass, as I say, it just burns through the calories at a massive rate while just being sat here. And the muscle also makes me look good, etc., etc. And because I'm muscular, I can go to the gym, rep out, say, on the bench press for 100 kilos, 140 kilos on the squats and deadlifts. And in that hour, because my basal metabolic rate is so much faster than someone who doesn't have 40 pounds of muscle tissue that I've added, and also they can't lift the heavy weights and such, is during that hour I burn hundreds of calories more than a person who has an average amount of tissue on their frame, you see. And also, by the way, is you can cleverly use the periphery as a glucose sink, so you can have these strategic carb load meals, which don't set you back. In fact, it might actually, advance your progression in terms of, body compositional change, and it allows you to have a mental break from the diet. So, for example, tomorrow, because my strength has gone down, I'm feeling a bit flat, is I might go have an Indian curry when the restaurant opens. So there we go. Okay, that's how it's done, Left arm's a bit smaller, but not too bad either. Okay, so there you go. Clozapine Fit and Lean signing out.